Hi, welcome to this lesson on calculus optimization problems. Let's have a look at a checklist for optimization problems. So to find the point or points that are either a maximum or minimum of a function, we need to do the following procedures. First of all, based on the context of the question, you want to identify the correct function f. Okay, so some examples, for example, as we saw, the function, we could look at the temperature of boiling water in a kettle, for example. We could maybe have a look at the area of some sort of gated fence for a farm, for example. We could have a look at the volume of a cool drink can to see how much cool drink we can hold in there. So the function f that you want to end up creating must depend on the context of the question for your optimization problem. Once you have that correct function f, which you know will be the correct one because you either want to maximize or minimize things like temperature or area or volume, then once you have that, the next step is to set the first derivative, so calculate it, and then set it equals to 0. So f prime x equals 0. That is your important part. Only once you have the correct function f based on the context, then set that first derivative equals to 0. So this correct function f here is the hardest part because there might be some manipulation you need to do in order to get that function down to one variable. Because sometimes there might be interplay, for example with area, you might have two dimensions, an x and a y dimension to find an area. So you might have to get one of the variables in terms of the other one. So there's some sort of algebraic manipulation that needs to happen beforehand, that we only end up with a function of one variable. That's really important, because you only want a function of one variable. In this case, in general, the variable x, okay? Then you want to solve for that variable in question. Okay, so when you set f prime x equals to 0, so it's some function of your variable equals to 0, then you want to solve for that variable x. Okay, then once you've got that, at that point, the original function that you deduced will either have a maximum or minimum, depending on the form of the function. So you substitute that value of x into the original function, okay, and it'll give you either a maximum or minimum value depending on the context of the question. All right, so this is the general methodology for solving optimization problems. Again, identify the correct function. There might be some necessary algebraic manipulation to get it down to a variable with just one variable, right, the function of one variable. Then once you have that correct function, find the first derivative of it and then set it equal to 0. Then solve for the variable. Then that variable will be the point at which your original function either has a maximum or minimum. So you need to substitute that value back. It doesn't end at that value. You take that value and you substitute it back into the original function, and that'll give you either the maximum or minimum value of that function. All right, I'll see you in the next one.